So we are going to discuss rectangular parallelepiped or cuboid from chapter 4 of Ganit Prakash, class 10. The shape of a parallelepiped or cuboid. This type of shape is called a parallelepiped. Now, this looks like a matchbox like this. Okay, a parallelepiped or a cuboid. This shape is a parallelepiped. Here you will see that how many surfaces we have. One opposite, two surface here, two surface, 4, then 5 and 6 surfaces here. Then how many edges we have? Edges are where two surfaces meet, that line. You see this line here, this is an edge, this is also an edge. This surface and this surface meets at this edge. So how many edges are there in a cuboid? We have 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, then 11 and 12 edges, right? And two opposite sides of a cuboid are equal and parallel. This side is parallel to this side. Also this side is parallel to this side and they are both equal. This side is parallel to this side and they are equal, and so on. You will see here this is one surface, this is parallel to this surface. Okay, this is one surface 1 and this is surface 2, then surface 3, then opposite surface 3, then surface 4. Okay, then we have this surface 5 and opposite is surface 6. Okay, and you can see that the opposite surfaces are equal and parallel. Okay, this one is parallel to this side, they are equal and parallel. This side is equal to this side and they are both parallel. So in a cuboid we get some properties or characteristics that we have 6 surfaces. How many surfaces I showed you? Here you can see in a cuboid there are 6 surfaces, 1, 2, 3, 4, 5, 6. And how many edges? 1, 2, 3, 4, 5, 6, 7, 7, 8. Let me do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 edges here. The two opposite sides are parallel and equal. This one is parallel to this side and they are equal in size. This one is parallel to this side and they are equal, and They are equal and parallel. So that is the characteristic of a parallelopiped or cuboid. And any two adjacent sides, this side or this side, if you take this side and this side, you will see that they are perpendicular to each other. This surface and this surface, this surface and this surface, they are perpendicular to each other. Okay, so these are the characteristics of a parallelepiped or cuboid. Now let us discuss about length, breadth and height of a cuboid. What are these things in a cuboid or parallelepiped? You see, in a cuboid, this cuboid is on this plane. Okay, on this plane, this is the cuboid. Now, depending on the plane where the cuboid is placed, respective to the plane, this side can be taken as length. Usually the longer side is taken as length and the other side is taken as the breadth. So this is the length and this is the breadth. So that leaves us with height. So the remaining side, which is vertical to length and breadth, is the height. So if this is length and if this is breadth, then this is height. Okay, so remember one thing, that length, breadth and height are relative to the plane. Now if the plane changes or if you rotate the cuboid, then one side, the side which was length can become the height, or the side which is breadth can become the height. So it depends on the plane or the orientation of the cuboid, how you place the cuboid. If you place a cuboid like this, then this can be the length and this can be the breadth and this is the height. If you rotate it, then this can become the height, this can become the length, this can become the breadth, and like that. Where you place the cuboid and how you place the cuboid, that is also important. And depending on that, we say this is length, this is breadth and this is height. So here, with respect to this plane, this is the length, this is the breadth and this is the height. Okay, so like this, if you said this is the cuboid, let us bring back this matchbox example. This is the cuboid. Now on this plane, I will say this is this length of this surface, this is the length. Okay, then this is the breadth, this is the breadth. Okay, and then this will become the height, length, breadth and the vertical one, that is height. Now if you rotate the cuboid, then this one, the definition of length, breadth and height will change. Now this can become the height. Okay, this can become the length and this one is breadth. So it depends where you place and how you place the cuboid. So here, so we have understood what are length and breadth and height of a cuboid is. What are the lengths and breadths and height, length, breadth and height of a cuboid are. These are measured with respect to the plane on which the cuboid exists. Now if you change the rotation, if you rotate the cuboid, then the definition of length, breadth and height can change. Okay, but the subsequent calculations that we will do using these properties, length, breadth and height, they will not change. Okay, I will show you shortly, but the definitions can change depending on the orientation of the cuboid. And one more important concept is the concept of vertices. So what are the vertices? You can see here that this point, meeting point of this plane, and this plane, and this plane. Sorry, this plane, and this plane. This point, this is a vertex. Okay, this is another vertex. This is another vertex. This is another vertex. How many are there? 1, 2, 3, 4. Then 5, 6, 7, 8. How many altogether? So there are 8 vertex or vertices in a cuboid. Let us take the matchbox example to show you physically. In this matchbox, you can see this is the vertex 1, then 2, then 3, then 4, then 5, and 6, 7, and 8. So there are 8 vertices in a cuboid. Okay. One special case of a cuboid is the cube. Okay, this is a cube. So what is the speciality of this cube? Like a cuboid, it has 6 surfaces, then it has 12 edges and 8 vertices, just like a cuboid. Now the special thing about cube is that its length, this is the length, this is the breadth, and this is the height. Okay, this height, all length, breadth, and height, they are equal in length. So length, breadth, and height of a cuboid are equal. That is the speciality of a cube, which is also a cuboid. Okay. So we have understood what is a cuboid, what are the properties, how many surfaces it has, 6 surfaces, how many edges it has, and how many vertices it has. So a cuboid has 6 surfaces, 12 edges, and 8 vertices. The surfaces, the opposite surfaces, are parallel to each other, and they are also the opposite surfaces are parallel to each other and also equal in length, equal in size. Okay, so this side is equal to this side is equal to this side, and this side is equal to this side, and they are also parallel. Then we come to vertices. 2 surfaces adjacent sides meet at the edge. 2 adjacent sides of a cuboid, they meet at the line which is known as the edge. So this is the edge, this surface and this surface meets at this edge, and so on. This is also an edge, this is also an edge, this is also an edge, and this is also an edge. Then we have vertices. This is a vertex. Okay, so all the 3 edges meet here. This is a vertex. Okay, this is also a vertex. So how many vertices we have? Total we have 8 vertices. Okay, and what are the properties? What are length, breadth, and height of a cuboid? So depending on how you place the cuboid, any side can be taken as length. Usually the longer side is the length, then the other side is taken as breadth, and the side vertical to length and breadth, that is not taken as the height of the cuboid. And a cube is a special cuboid where length, breadth, and height, all 3 are equal. Okay. So in the next chapter, we are going to delve into little more depth about how we can calculate the surface area of a cuboid. In the previous class, we talked about, discussed about cuboid and special case of a cuboid, which is the cube where length, breadth and height, they are all equal. And there are 6 surfaces of a cuboid. This is the cuboid. I showed you this example of a matchbox. 1, 2, 3, 4, 5, 6 surfaces, and there are 12 edges where the surfaces meet. This is 1 edge, this is 2 edges. There are 12 edges like this, and there are 8 vertices. This is one vertex, this is another, this is another, this is another, this is another, and so on. So we have 8 vertices on a cuboid. And we also discussed about length, breadth and height of a cuboid. What are the length, breadth and height of a cuboid? How we can and in today's class we will discuss about how we can use this length, breadth and height. Okay. So the length, breadth and height depends on which one is length, which one is breadth, which one is depends is breadth, height. All this depend on the orientation or where the cube is placed. Okay, which plane the cube is, the cuboid is placed. Okay, it means a lot. If you rotate the cuboid, then the length, breadth and height will change, and the orientation matters. Okay, the plane where cuboid is placed or the cube is placed, that matters a lot. So which side you will consider length, which one side you will consider breadth, and which side will be height, that will depend on the orientation of the cuboid. Okay. Now in today's class we will find out some values of this, some properties of this cuboid, how to find the area and volume of a cuboid with the help of length, breadth and height. That is what we are going to discuss today. So as you can see, this is a cuboid. I have already given you an example. The matchbox, this is a cuboid. This is a cuboid shape, and this is the special case of a cuboid, which is a cube. And to find the surface area, how to find the surface area, total surface area of a cuboid. So this is the cuboid, and we are required to find the total surface area. Add all these areas and we have to find the total surface area. So how to find the total surface area? You already know there are 6 surfaces, 1, 2, 3, 4, 5 and 6. There are 6 surfaces here. Okay. So we have to total all the surfaces, the area of all the surfaces, and find the total surface area. So how we can do that? Let us see. So what is the area of the topmost, this one, this face, the topmost face, this one? You see, this is the length and this is the breadth. So how do you find the area of this face? This topmost face, you find it length into breadth, right? And since there is a opposite side to this face, you see, this is the face and this is the opposite face. Okay, this is one face, this is the opposite face, both are equal. So since they are equal, their area will also be equal, length into breadth. Okay, so when we add both of them, we get twice LB. So area of this face and the face directly opposite to this is twice LB, length into breadth. So this is this surface and this surface. You add them, you get twice LB, L into B, L into B. So twice LB, length into breadth. Similarly, let us consider this area. Okay, area of this face. You can say that this face. Okay, this face. So here it is the breadth. Okay, from here to here it is the breadth, and from here to here it is the height. So the area is breadth into height, and the area of the face opposite to this one is also breadth into height. So adding them, this one and this one, we get twice breadth into height, right? So let me explain it again. See, this is the area. We have to find the area of this face. This is breadth into height. Okay, this is also breadth into height. So we have breadth into height plus breadth into height, twice breadth into height. Similarly, the last one, this face and this face. You see, this face is length, this one is length, and this one is height. So the area of this face is length into height. Similarly, the area of this face is also length into height. So twice length into height, we get twice L into H. So in total, we get the total surface area of all the faces of this cuboid, okay, is twice L plus B. You have to add them, plus twice BH plus twice LH. Okay, so taking 2 common, we get L into B, B into H, and L into H. So this is the formula for total surface area of a cuboid. If we know the length, breadth, and height, we can apply this formula to find the total surface area of a cuboid. Okay, clear? Now, this cube is a special case of a cuboid. Okay, here the length, breadth, and height all are equal. Say they are equal to A, suppose. Okay, so if you substitute this value here, what does it become? A into A square, A into A, again A into A square, A into A, then again A into A square. So this is equal to 2 into 3A square, which is 6A square. So this is the formula for surface area of a cube, which is a special case of a cuboid. Okay, so we get two formula, actually one formula, that this is the formula for total surface area of a cuboid. Okay, and this is the formula for the total surface area of a cube. If we know the length, breadth, and height, we put the values here and we get the total surface area. In case of a cube, we just have to know length or breadth or height, because all three are same. So we get 6A square, that will give us the total surface area of a cube. Let us take an example. Suppose the length of this length is equal to, say, 25 centimeter, and the breadth is, suppose, 13 centimeter. Okay, so what is the area of this face? That is L into B, that is 25 cm into 13 cm. So 25 into 13, whatever it is, we calculate later. It is written as cm square, and it is said that the area of this face is 25 into 13 square centimeter. Okay, you don't say cm square or centimeter square, you say square centimeter. That is how we express area. Okay. Now if it is, say, in place of cm, it is just meter, then it will be meter, and it will be meter. What is 25 into 13, by the way? $325. Yes, 325. 325. So if it is meter, then you say that it is square meter, or 365 square meter. So that is how the area is expressed. Okay. If it is in centimeter, so we say that it is in square centimeter, and if it is in meter like this, we say it is in square meter. Okay. So remember this. So what will be the total surface area? If you know the height, then you multiply, you use the formula 2 into L into B plus B into H, L into H. If you know all the values, then you replace the values, then you find out the total area. So it will be either square centimeter or square meter, or it may be square kilometer also, or maybe millimeter also, depending on how you measure the length. Okay. So you always use the square word first. Square centimeter, square meter, or square kilometer, or square millimeter, like this. Okay.